All right. 0 is a polynomial. This is section 7.5. And we're going to have to cover this in 2 sections, in 2 days. So 7.5, part 1, I guess. Now, what is that? Now, how do I get rid of that? There we go. All right. Rational roots. Somebody tell me what a rational root is. What's rational? Real. And what? Perfect. Rational roots able to put in fractions. Yesterday you had roots that were irrational, didn't you? When you have plus or minus square roots, right? If there's going to be rational roots to p of x equals 10x cubed plus 9x squared minus 19x plus 6. If there are going to be rational roots, it is going to be all factors of 6 over 10 of the constant over the leading coefficient. It's going to be all factors, if there's going to be rational roots, all factors of 6 over 10. And all combinations. And I'll tell you what I mean by that. The factors of 6. 1, 2, 3, and 6. Now, if it's a rational root, it could be a negative one too, because it could be negative 1 times negative 6, correct? So it's plus or minus on all of these. Right. If there's going to be rational roots, it's going to be all factors of 6 over 10, and all the factors of 10, 1, 2, 5, and 10. Okay? You're going to have a question, and I want to make sure I have this on recording. There's going to be a question on your next test that says, list all the possible rational roots. You don't have to find them, you're just going to list them. And here's how we list them. It's all factors of 1 over 1, 1 over 2, 1 over 5, 1 over 10. So here's all the possible rational ones. Plus or minus 1 over 1, plus or minus 1 over 2, plus or minus 1 over 5, plus or minus 1 over 10. And then we have to do the same thing with the 2 on top. Plus or minus 2 over 1, plus or minus 2 over 2, which is 1, and I've already got that. Plus or minus 2 over 5, plus or minus 2 over 10, and I've already got that one, 1/5. All right? And then plus or minus 3 over 1, plus or minus 3 over 2, plus or minus 3 over 5, and plus or minus 3 over 10. And then finally, plus or minus 6 over 1, plus or minus 6 over 2, got that? 3. Plus or minus 6 over 5, and plus or minus 6 over 10, which is 3/5, and I've already got that one. These are all the possible rational roots. All right? So, let's use synthetic division. I have 10, 9, negative 19, and 6. Which one do you want to try?
3.
Now, because there's so many of them, this is what we had to do before calculators. There's all kinds of tricks involved, but you can eliminate some of these. One of the tricks was, how many sign changes are there in the original polynomial? It goes from a plus to a plus to a minus to a plus, so there's 2 sign changes. That tells you that there's either 2 positive roots or 0 positive roots. And then we had to put in a negative number for x and then figure out the sign changes. All right. So there was things where we could eliminate some of these numbers. we have the advantage of calculator. So what we want to do is we want to go to your calculator, and I'm going to plug in, and my y equals 10x cubed plus 9x squared minus 19x plus 6, and I'm going to find one of them. What would you say 1, 0 is then? -2. And that is on our list. All right? So we use synthetic division. Okay, it is a 0. And what it equals is 10x squared minus 11x plus 3. And what do we do with that? Factor it. And I'm going to try 5x and 2x. And we'll try 3 and 1. 15 and 2. Does that work? No. We can't get 11 from 15 and 2. So let's try 3 and 1 here. 5x and 6x. Yeah, that gives me 11x. It's a guess and check. And so what are the other two zeros then? 1/2 and 3/5. Is that in my list of possible ones? Yes. You can't really tell those by the graph. So really what happens there, if you look at the graph, doing this on your calculator, it looks like it just touches the x-axis. But if you were to zoom in, you would see that it comes really below that axis and then back up again. And it crosses at 1/2, and comes down a little bit, then it comes back up at 3/5. So there are 3 rational zeros. Yes, sir?
Where did the -2 come from?
The -2 came from looking at the graph on your calculator.
Oh.
Okay? It saves you the time of going through this whole list. Some of these are easy enough to do, but some not. All right? You have a quiz question, I'm going to repeat it again, where it says list all the possible rational roots. And what I'm looking for, list all the possible ones, I'm just looking for that. And that's as far as you have to go. That is one test question. Okay? Just one what? Yes, just one of those questions. List all the possible. You got that? All right. So I've got a couple of other polynomials written up here. All right. You know, this one's a little bit easier because it's all factors of 1 over 1, which would simply be plus or minus 1. So in a lot of these, there's not a lot of numbers to check. But because we have a calculator, we're going to graph it. And I'll put in x cubed minus 2x squared minus 2x plus 1. All right. Can you tell me by looking? Now look, if there's going to be rational ones, what are they? Plus or minus 1. Looking at your graph and your calculator, which one is it? Looks like -1, isn't it? Right? Looks like -1 is going to be a 0. So let's use -1 and use synthetic division. 1, -2, -2, and 1. We think it's going to be rational. It looks like it's -1. Yes. So now I have x squared minus 3x plus 1. And guess what? It doesn't factor. It doesn't factor. So what are those other two zeros? They're not really imaginary. They're irrational. They're not really imaginary because if you look at the graph, they do cross the x-axis. So they are real. They do cross the x-axis. So what do we have to do to find it? Quadratic formula. The quadratic formula is opposite of b plus or minus the square root b squared minus 4ac all over 2a. So let's do that. To find x, it's equal to the opposite of b plus or minus the square root. And I like to do the discriminant. I like to do that over to the side. B squared minus 4ac. 9 minus 4, 5, all over 2a, or 2 times 1. So now my zeros are negative 1. We got that from the graph. And then I have 3 plus the square root of 5 over 2. And 3 minus the square root of 5 over 2. Those are my 3 zeros. Pretty hard to tell from the calculator when you want to get those exact answers. All right, so far? Let's do another one. Let's do this one here. P of x equals 3x cubed minus 10x squared plus 10x minus 4. Go to your calculator. X cubed minus 10x squared plus 10x minus 4 and graph. Now all the possible, and we can find them, all the possible rational roots are going to be 4 over 3. So it could be plus or minus 1, plus or minus 2, plus or minus 4, over plus or minus 1, plus or minus 3. So I have plus or minus 1 over 1. It doesn't look like it's going to be plus or minus 1, does it?
No.
No. Plus or minus 1 over 3. Doesn't look like it's 1/3 either by looking at the graph and the calculator. Plus or minus 2 over 1. Could that be it? Looks like it's 2. Okay, so let's try 2. It didn't fall right over 2, but who knows with calculators? Okay, so let's 3, negative 10, 10, negative 4. We're using synthetic division. 2 times 3 is 6. We have negative 4. 2 times negative 4 is negative 8. 2, and 2 times 2 is 4. And yes, 2 is a 0. Now I have 3x squared minus 4x plus 2. This is called a depressed polynomial, by the way. We almost never use that vocab, but, and this is not going to factor. I'm going to tell you right now, it will not factor. What can you tell me, looking at your calculator and looking at the graph, what can you tell me about the other 2 zeros? They're imaginary. And how do we find them? Well, quadratic formula. The opposite of b plus or minus the square root of b squared minus 4ac. 4 times 3 times 2 is 24. 16 minus 24 is negative 8. And there's my imaginary. All over 2a, or 2 times 3. Okay. So I have 4. Can you tell me what the square root of 8 is? Simplified. 2 root 2, right? Plus or minus, but because it's a negative, it's 2i root 2 all over 6. And that can be reduced by 2. So I have 2 plus or minus I root 2 over 3. My zeros are the one that we found in the calculator, 2. And then I have 2 plus I root 2 over 3, and 2 minus I root 2 over 3. And those are my 3 zeros. We found 1 rational and 2 imaginary. The first example I gave you was 1 rational and 2 irrational. Okay, these are real. All right, do you have any questions? That's as far as I'm going to take this one. Doug?
Are you gonna ever have a problem where it ends up being 2 rational and 1 rational?
2 rational and 1 imaginary? No. If it's going to be, if you're going to have 1 imaginary, then its conjugate is also going to be a root, because you have the plus or minus situation. And that's what we're going to deal with next Tuesday. Okay. All right. So, your homework for tonight is going to be pages 463 and 464. I'm going to give you the odd problems. So that when you're sitting in front of the fireplace doing math tonight, you'll be able to check your answers in the back of the book. So that's my little weekend gift to you guys.